So what's up friends, it's Prosper here again, and here is another tutorial video. And in this video I'm about to show you guys is how you can deal with algebraic expression. So in our previous class we discussed about letters and numbers, and letter and number is actually the primary state of how you can deal with algebraic expression. So quickly, what I'm about to show you is how we can start from the easy to the complex part of algebraic expression. So algebraic expression is all about letters and number, how you can manipulate letters and number to get a final answer. And you know that in algebraic expression, sometimes letters stand in place of a number. So quickly, without any time wasting, because we'll be time conscious, and if you have any question, ensure you drop your question in the comment section below. I will be willing to answer any of that promptly. So as we're giving, let's see the shortest possible way of writing some of this algebraic expression. So let's assume we're giving a plus a plus a. So a plus a plus a is just a statement. Now how many a do we have there? We have 1, 2, 3. So in this case, our final answer equals to what? 3a. Alright, so next we have, if we're giving, let's assume we have z plus z plus z plus z plus z plus z. And how many numbers they might appear? So what you just got to do is to count the numbers of z. You have 1, 2, 3, 4, 5, 6. So in this case we have just cz. So this is all about algebraic expression. So let's move in when, so let's see what is the meaning of coefficient and what we've just done. So in this case, what is the coefficient of this a? So the coefficient of this a is what? 3. Coefficient means for something to coexist. How many times is it existing in this expression? So a is existing in this expression 3 places. That makes it 3a. So 3 is the coefficient of a. So let's see some coefficients. Now let's assume we're giving 1 over 2x. So what is the coefficient of x here? So the coefficient of x is 1 over 2. As simple as that. So if we're given 3x over 5, so in this case, what is the coefficient of x? The coefficient of x is just 3 over 5. So this is as easy as you can think. So let's move into positive, grouping positive and negative terms. So let's move into what? Grouping. So let's see grouping positive and negative terms. So let's assume we're giving 1, we're giving 18j plus 7j. So 18j plus 7j means 18j in 18 places plus j in 7 places. So what you just got to do is to add the numbers. 18 plus 7, 18 plus 7 gives us what? 25. So in this case we're having a total of 25 j's. Simple. So let's assume we're giving another example, and we have 5y plus 13y plus 2y. So 5y plus 13y plus 2y. So let's see how many are there. So don't let it get you confused. All what you just gotta do is to add the numbers, because the number shows how many times the y are appearing. So in the first one, y is appearing 5 times. In the second one, y is appearing 13 times. In the third one, y is appearing 2 times. So 13 plus 5 will give us 18. 18 plus 2 will give us 20. So in this case, we have 20 y's. So let's see when we're having a positive and negative altogether. So let's assume we're giving, for example, 3, we're giving 10b plus b minus 3b. So 10b plus b, remember an ordinary b is 1b, because if I say just b, how many b are here? Or how many b? Yes, how many b is here? We just have 1. So instead of writing 1b, we can just note 1b as just b. But when it's more than 1, we mostly note the coefficient. But if it is 1, 1 is mostly not written. So in this case, 10b plus b just means 10b plus 1b, which is 11b. So we have 11b minus 3b. So 11 minus 3 will give us 8. So we have total of what? 8b's. So let's see for question 4. We're giving 6w plus 4w minus 3w minus 2w. So first you add, then you subtract. So you can say 6w plus 4w will give us what? 10w's. Minus 3 minus 2 is minus 5. So we have 10w minus 5w's. So 10w minus 5w will give us 5w. So that will be our answer. So this is as easy as you can see. So let's take another example for clarity. Let's say we are taking example 5, and we have 4m minus 22m plus 13m plus 10m minus 3m. So in this kind of things, we do what we call collecting like terms or sorting. Trying to evaluate this expression, it might look kind of, you understand what I mean? It might look a little bit hectic due to the fact that we're having some bigger negative, smaller positive, bigger positive, smaller negative. So we collect like them, we sort or rearrange. We call it rearrange. So in this case, we can say 4b, let's take the positives. So we have plus 13m, sorry. Then we have 10m. Then let's take the minus 22m minus 3m. So in this case, you can say 4m plus 13m plus 10m. So 13 plus 10 is 23, 23 plus 4, 27. So you can say this is what? 27m's. Then minus 22 minus 3. 2 and 3 is 5, right? So we have total of what? Minus 25m. Minus 25m's. So 27m minus 25m will give us a total of what? Just 2m. And that's our answer. So the rearranging in algebraic expression is very essential because it will help you to analyze or figure out your evaluation real quick. So let's clean some part of the board so we can use it. So let's take some other further examples. So let's move into grouping like and unlike terms. Grouping like and unlike terms. So under this, so we're done with grouping positive and negative. So now let's go with grouping like and unlike terms. So let's assume we're giving example 1. We're giving 7y minus 3x plus 4y. So remember, this 7y means y plus y plus y plus y plus 5 plus y up to the 7th place. X minus 3x also means x plus minus x minus x minus x, making minus 3x. So x and y are two different letters, so they are not the same. So in this case, what we have to do is to what? Rearrange. So I will just indicate with arrow to rearrange. So what we're going to do here, we're going to bring y to y and have x to x. So we see 7y plus 4y minus 3x. So 7 plus 4 will give us the total of 11. So we have 11y, then we bring this minus 3x. So since there's nothing else to do, this is our final answer. So let's take another example from example 2. So let's assume we're given 12n minus 3p minus 3p minus 5p. So we have p, just one n, so we have nothing to do with n in this case. All we have to do is to concentrate on these p's. So minus minus minus, so you remove 3, you remove another 3, you remove the total of 6, then you remove another 5, so you should remove the total of 11. So minus 3 is minus 6, minus 6 minus 5 is minus 11. So we can say this is what, or let's use money to analyze this. You are owing 3 naira, you went back again and borrowed another 3 naira, you have borrowed a total of what? 6 naira, and you went there again and borrowed another 5 naira. So the 6 naira you are owing plus the new 5 naira you borrowed have made you owe the total of what? 11. So that is well explained. So we can have this as 12n minus 11p, and that will be our final answer. So let's see for question 3. So let's assume we're giving 4y minus 2x minus 5x. So sorry, it should be the network that is not making this writing very clear as we want. Then minus 3y also. So in this case, we will say, let's rearrange this. Rearranging is very essential. So rearranging, we'll have this as 4y, then we'll bring this other y minus 3y, then we have minus 2x minus 5x. So 4y minus 3y will be 1y. So 1y will be noted as just y. Then minus 2 minus 5 is minus 7. So we have minus 7x. And that is our answer. So let's take another example, for example 4. So in this case, we're given 8a minus 5a plus 14 minus 6. So this is already arranged, so no need of rearranging in this case. So we just say 8a minus 5 is just like 8 minus 5, that is 3. So 8 minus 5 is 3, so we have it as 3a. Then plus 14 minus 6, just like 14 minus 6, 14 minus 6, that should be 8. 14 minus 6 is 8, so we have it as just plus 8. So this will be our final answer. So let's see we're giving, let's see
no, she now. How are you?
Good evening.
Hello, good evening. Do you work here?
Yes, I do.
Yes, Beatrice. How now? Fine. How was the career day?
It's fine.
They didn't send us any picture, no video.
It will be uploaded soonest.
Okay.
Alright.
I hope you read your career choice. You read that.
Yes,
Did
right.
you open your mouth? Yes. Did they give you your food? No furniture.
Alright.
Bye. Miss Beatrice. Bye.
Have a nice weekend. Alright, so let's take another example. So let's have a case whereby it seems more complex, but let's analyze it. So let's assume we're given 6p minus 2q plus 4r minus 2p plus 3r plus 5q. So in this case 6p, so let's analyze this. In this case you just need to want to rearrange. So in this case I will say, let me take my 6p as my 6p starting. So where are the p's? We have just one p extra, which is minus 2p, q, okay, we have minus 2q plus 5q plus 5q. So we have r plus 4r plus 3r. So let's see, are they complete? 2, 4, 6, 2, 4, 6. Okay, 6p minus 2p, that is 6 minus 2, that is 4p. So we have 4p minus 2 plus 5, just like 5 minus 2, that is 3 plus 3q. Remember, this one having the minus sign, that is the subtraction sign, is smaller to the one having the positive sign. So our answer will be in positive. So ensure you have that couple. Then plus 4r plus 3r, 4 plus 3, 7. So we have plus 7r. And that's our answer. Sorry. Okay, so let's continue. So let's see. Okay, now we're moving into the complex part of algebraic expression. So all we'll be doing is a scratch of what we're about to dive into. So stay tuned and ensure you write any of your questions in the comment section below. As I told you earlier on, I'll be willing to answer every of your questions from you. So do not hesitate to ask your questions. So right now we're moving into multiplications of with algebraic expression. So we're moving into the multiplication aspect of algebra. So let's quickly wipe up the board. So sorry about the distraction we had. Right now I'm in the school where I teach. I teach in Dostam School, so ensure you bring your pupils to Dostam School. It's located at F bus stop. Once you get to F bus stop, so at the BC Ogunniyi block 113. Yes, to be very precise, or you can drop me a DM of the location. I might not remember it off hand. So ensure you have your pupils registered in Dostam School to meet great teachers like me. Yeah, I'm a great teacher. So stay tuned. Alright, so continuing. So when what? Multiplication with algebraic terms. So let's quickly take some exercises here. So exercise 1, if we're given 5 times a, 5 times a is 5a. So you are saying a times 5, that means a multiplying in 5 places is 5a's. I get me? So exercise 2, if we're given 5 because this a can stand as, okay, let's assume we now say where a is equals to 4. So 5 times a, replacing a with 4, we have 5 times 4. And 5 times 4 is what? 20. So this, in this case, this 5a is representing 20 only if where a is 4. That is why they came together as 1. So let's assume we're giving, sorry, it's not 5 on the right, y times a. So y times a will become ya or ay, because alphabetical order a comes before y, but because in the expression we are having it y times a, so it becomes ya. You can write ay, anyone. It's just like saying 4 times 5. You can also equally say 5 times 4. 4 times 5 is 20. 4 times 5 is 20. 5 times 4 is 20. So any which way you have them front or back, they will still give you the same answer. As we have 5 times 4 is 20, if I write here 4 times 5, what will it give me? It also give me 20. So that's how it goes. So let's take another example, for example 3. For example 3. So assuming we're giving 2a times 3. So 2a times 3 will become what? 2 times 3 is 6, so we have it as 6a. 2a times 3, 2 times 3 is 6, and attachment will be a. So that's this. So let's take another example, example 4. So let's assume we're giving 16 times 2x squared. So 2 times 16 will give us 2 times 16 will give us 32. Yeah, I'm very sure about that. 32, then we'll add the x squared to it, so we become what? 32x squared. So let's take another example, for example 5. So let's assume we're giving 4ab times 7a. So 4 times 7 is 28, right? 28. Now remember, if we are giving a times a times a times a times a equals to a cubed. Now this has bring us into the word we call indices, and indices also means power, and power means index, the index form. So if we're having a to power 3, that means it means a appearing in 3 places in multiplication. Are you getting it? So it means a appearing in 3 places multiplying themselves. So if you write a to power 3, it means a times a times a. Remember, don't go and write when we're having a times a times a. You're going to write 3a. I will flog you. I will wrong your work. A times a times a is a to power 3. It's only this when it is a plus a plus a. A plus a plus a, that's when you can have it as 3a. So this is wrong, this is correct, and this is correct. So have that in mind. When it is times, the number goes as power. When it is addition, the number goes as a coefficient. So keep that in mind and stay concentrated. So in this case, continuing, now remember we have an a here and we have an a here. So this a times a becomes a squared. So we have a squared. Then there's just only one b. So we assume the b is multiplying 1. B times 1 is 1b. 1 times b, just as say 5 times a is 5a. So 1 times a is 1a. And ordinary 1 to a number is just the same letter. I mean, a letter multiplying 1 is still the same letter. So b multiplying 1 becomes just b. So we have our answer as what? 28a squared b. So let's take another example, for example 6. So assuming we're giving 6y times 5xy. So we say this is what? 6 times 5 is 30, right? Then y times y is y squared. X comes before y, right? So let's say we have the x here, or let's make it power. The power should be, so y times y is y squared. Then we put our x, because x is not multiplying anything than 1 in that case. So this is our final answer. So our answer is what? 30y squared x. So let's take another example for example 7. So in this case, let's see something a little bit. Okay, let's assume we're given 1 times x squared. What do you think the answer will be? I'll give you 1 minute to do that. Okay, so 1 times x squared will just be what? X squared. But we said it earlier on that 1 times anything is still the same thing. 1 times 1 1, 1 times 2 2, 1 times 3 3, 1 times 4 4, 1 times 5 5, 1 times 1 million 1 million. So 1 times anything is still the same thing. Keep that in mind and you have that understood. So let's take another example. Example 8. That's just wrapping it up, then moving to the next step. So x times 3x times x. So 3 times, there's an invisible one here, is 3. X times x is x squared. So that is our answer. So with this, I'm very sure you've understood everything that has to do with what? Multiplication with algebraic terms. So let's move into the divisional aspect. So let's say division with algebraic terms. Sorry, let me quickly send a message. 1 minute. Sorry. Alright, so let's move into the divisional aspects of this. So for the divisional aspects, please pay very good attention because this divisional aspect might kind of understand. So let's take example 1. So example 1, we give him so I'm going to show you in 2 method form. So you just tell me the method you like and stick to that method. So we have 6a over 3. 6a over 3. So you can use the direct divisional style, or you call it the separation style. Like, assuming I'm having this my denominator as 3, I can say 6 times 3 times what will give me 6. So I can say it is 3 times 2. As we okay, let me put my times a. 3 times 2 will give me this 6, right? Then times a. Then I can put my 3 here. So in this case, 3 will divide 3 1 times. So what do we have left? We have 1 times 2 times a. 1 times 2 times a all over 1, because this 3 has divided 1 time also here. So next thing we can do here is 1 times 2 to 2 times a is 2a. 2a over 1 still means 2a, because anything divided by 1 is still the same thing, and as we said, anything multiplied by 1 is still the same thing. So let's take another example, for example 2. So we're giving 18y divided by 6. So rearranging this in the divisional style or in the fraction way, we can see this can be noted as 18y all over 6. So, and as I said earlier on, I'll show you 2 styles. Let me show you the second style. The second style is going back to this question 1, right? Are you with me? Alright. So going back to this question 1, I can see 3 can divide 6, right? So 3 here 1, 3 in 6, 2. So I have my answer as 2a direct. So having this also, using that same method in this form, I can say 6 can go in 18, right? So let's count in 6 times 2. I can say 6 times 1, 6 times 2, 26 times 3, 18. So since 6 times 3 is 18, that means 6 can go in 18 3 times. So you can say 6 here 1, 6 in 18 3 times. So we have our final answer as 3 and y becomes 3y, and that's our answer. So you can do that furtherly with this more expansible method. Yeah, hope my English is correct. I'm a mathematics teacher, so don't make it a guide, okay? Alright, so let's go straight for question 3. So in question 3, they're giving us a divided by a squared. A divided by a squared. So this means noting this in a fractional way, we can see this is what? A all over a squared. So more expressing this, remember I told you when 18 is by power, you have the number appearing by the power in multiplication form. So I can say this is what? A all over a times a, right? So a can cancel a. So a here 1, a here 1. So I have, what am I having remaining? 1 all over 1 times a is a. So this will be my final answer. So my answer is 1 all over a. So let's assume we're giving another example, for example 4. And this is looking like 18 a cubed all over 3a squared. 18 a cubed all over 3a squared. So having that, we can say this is what? So first of all, let's express this so that you'll be able to understand every moves I'll be taking. So 3 times what will give me 18? 3 times 6, right? So I can say this is what? 3 times 6. So a cube is what? A times a times a. Remember we did a times a times a is a cube, right? So we can also note this a cube as a times a all over 3 times a times a, because a is appearing twice. So now we can say this killed this. That's what we use here in Nigeria, okay? So this one killed this one, this one killed this one, this one killed this one. So let's see what we have left with. So we have left with 6 and a. So we have 6 times a all over, all these are 1 1 1, so no need all over 1. So 6 times a is 6a, and that is our final answer. So let's furtherly take some examples on it. Alright, my network is poor, so my Microsoft whiteboard is kind of doing like it has, should I speak picture? Doing like it has banner. No banner. Let's forget about that. So let's take another example. So let's assume we're giving an example as this, and we have 48 x squared y all over 12xy. So this will be what? 12 times what to give us 48? 12 times 4. I'm very sure about that. So we have this as 12 times 4 times x times x times y. Alright, all over 12 times x times y. So 12 cancel 12, 1x cancel 1x, 1y cancel 1y. So what do we have left with? We have 4 here, 4 times We have 1x here. What else? We have nothing. All over all of this is 1, so we have 4 times x is 4x, and that's our final answer. So do we have anything a bit more complex? In case nothing is looking complex here, with all we've done, you can answer everything I'm saying here. So let's just hit one more. So let's take question 6. We're having 33 mn all over 3n. So in this case, we have this as 3 times what to give us 33 is 3 times 11, right? So we can say this is what 3 times 11 times n times n all over 3 times m. So 3 cancel 3, m cancel m, so we have left with 11 times n, which is equal to 11n, and that's our answer. So with this, we can call this lesson about division with algebraic terms to an end. So if you have any question or any exercise you're having difficulty with, ensure you drop it at the comment section below. I'll be willing to answer every of your question or exercise it at prompt. So let's see order of operation in algebraic expression. Okay. Alright. See you guys in the next class. Thank you.